So, welcome everybody. Today, I'm going to talk a little bit about how I use the Pony FFI to implement the Pony process package. I'll jump right in. Feel free to ask questions anytime during the talk. It's not that long, and I'm going to give an overview on how the process package works, and then show some code, how the code uses the FFI to do system calls. All right, let's do it. So why do we need the process package? We want to have something that can run non-Pony code outside of Pony in a safe way. We want to wrap that in an actor to make it natural for other Pony code to deal with an external process and communicate with it. We're using standard in, standard out, and standard error over a pipe. All the I/O we will implement will turn into a byte-seq. And that means that all external process interactions will be asynchronous, which is really nice. And if things do break, anything goes wrong with external process or one of the system calls, and we can't recover from it, we throw a process error, but it is not something that we throw as an error. It is something that we notify via the notifier with a typed process error. And of course, once this is all implemented, you can spawn as many external processes as you'd like. So usually this starts with a Pony process, which creates a process monitor and a notifier. And then you do a fork. And now you have something that is sort of an unfinished environment with only one thread. And it's very important to make sure that you don't mess around here, that you're ready and then just go ahead and you will execute. There's some background. Could you move yourself? Thanks. So here we forked our Pony process, and then we do the actual execv. And what we had before the forked portion of the Pony runtime gets replaced by the binary we're calling, which is any kind of Unix binary that we want to run. And that we established the pipes, which means that anything that we write to standard in, there's a write function in the process monitor, and then you can write to that, and it goes through the pipe to the external process, which receives it as standard in, and anything that the external process writes to standard out or standard error, we capture too. It goes to the process monitor via the pipe, and the process monitor sends that off to the notifier, which then can act on it. So how does this work? This is the code, the actual Pony code that run through it line by line. We create the pipes for standard in, standard out, and standard error. If it turns out we fail, we close all of them and then just error out. In case we succeed, we prepare the arguments ahead of time, and then we do an actual fork. That's our first system call where we use the FFI. We go into the fork, and now we have to match on the PID that we received. In case it's a -1, we know that the fork failed, and there's nothing we can do about that, we just fail. In case it's a 0, we know we're in the child process now, and we have to go ahead and actually run our command as fast as possible. And if it's neither -1 nor 0, we're still in the parent process and we continue as a parent, which means we're still in the Pony runtime. Now, once we call child, we duplicate the file descriptors and immediately call execv with the actual command we want to run in the fork process. If that fails, we have to exit because there's nothing we can do about that. And we see here that the exit v command, it looks just like it would in a C program, right? Except that we have to give it we have to define the return type, which is an I32. Same goes for the exit call we do here in case things go wrong. Just looks like a system call would look in a C program. So this is really nice. You can map that one-on-one from a C program where you know how to do those things to a Pony system call by the FFI. Now in the parent process, once we detect, hey, we're the parent, we create an asynchronous event for both standard out and standard error pipes, meaning that if anything, once this is registered, if any data comes in via the pipe, we receive an event and we can consume the event and then read from the pipe and hand that to the notifier. And then we do the close operations, which is in this case a Pony function I wrote that just wraps the closed system call and does some error handling. And here's an example for the duplicate function, system call, and the way I wrap that into in a Pony function. You can see in the head of the while that just looks like a normal C call would, except for again the type for you have to define for the return type. And we also do some error handling, as in once we've run the call in the head of the while, we fetch the system error in case we get a -1, which means something went wrong. And then we check if we got the -1 because our call got interrupted. And if that is true, we continue, meaning we try again. If it's not due to an interrupt, then we know that the call failed permanently and we call the exit function and leave. This is a way where we call, where we register the actual asynchronous I/O event, which also it looks like is an FFI call, but it calls into the Pony runtime. And here we see what happens in the Pony code when we receive an event, which is where it really gets interesting. We say, okay, now we have to read from the pipe. How do we do that? So we have the normal read operation that we know from any kind of C/Unix interaction with pipes. We read into a readbuff C string, which is essentially a pointer into an array, and we can also check how many bytes we read from there. And then again, we just in case things didn't go as expected, we check for the error number. Now we have to do the check for error number is very important. You have to do that right after you've issued the system call, because it might change. So anything you do in between might change your error number. So you have to check for the error right away. Now, what we do here is we match for the length of the number of bytes we've read. If it's -1, we check, hey, is that, so we got an error, is that because we got interrupted? That means we want to try again. Or is it because it's not an interrupt, and then we have to close the file descriptor. So that means we're done. Same if we read a 0 length also means we're done. Someone closed the channel, closed the pipe upstream from us, and we have to deal with that and just close it down. Once we're sure that we have data, we read that into an array, we truncate it to the correct size, and then depending on the file descriptor, that's the match FD, we call the notifier either for standard out or standard error, meaning the function that is defined in the notifier that will then deal with the data accordingly. We then add the length to our sum so that we know how many bytes we've read so far. And if we've read 4 kilobytes, we say, okay, we will yield. We're not going to continue in this loop, but we will yield. And we call a behavior in the process monitor actor that will then try again, meaning it will come back into the same behavior we have here and start reading again. But we yield to anyone else who might want to do something inside the actor, any other action. So coming to lessons learned, once you've played with it a little bit, and actually what I did is like I built some simple C programs just to get used to the types of system calls that I would have to make this work. And then you transfer that to Pony, and then the mapping is really one-to-one. The thing you have to keep in mind is you have to be very precise with the types. That might seem obvious, but if you get that wrong, things really fall apart, and there's nothing Pony can help you with if you get the types wrong. You have to make sure that anything, in this case, you do before the exit V is as minimal as possible, because once you've done the fork, you're in an environment that is not really, really safe, as in you cannot allocate memory safely, and you certainly cannot reclaim memory in a safe way. So make sure that if you do a fork or do anything else that is related to a fork, that you do all the preparation work beforehand and then just jump right into the exit. Then, of course, as always, managing fork processes is tricky. Same goes for file descriptors. We had quite a number of bugs initially that were related to managing of file descriptors, especially if you fork more than one process. If you have series of processes, you have to make sure that your file descriptors, as they get freed up and get reused and reissued by the operating system, really don't get used again inside one of the process monitors that are still running. And yeah, as I said before, be careful when you map the types, your C types to Pony types, and make sure that those are the actual types used by the system, as in read the man pages for the operating system you're running on. There might be differences between OS X and Linux and BSD systems, and there's certainly differences if you run this on a Windows system, which is not supported yet. But the intention, of course, is to have this work, the process package in this case, for Windows systems too. Questions? Are there any questions?
So what was the what did you struggle with the most when you were first getting used to the FFI? Like, was there gotchas that you weren't expecting that really caught you by surprise, or more with what?
Initially, because I was learning the FFI and Pony at the same time, there was a lot of going around, merry-go-round with just getting the types right so that I could do the things I wanted to do, as in call a function, right? Hey, I have an array here. How do I do a recover? All those things were interleaved with, okay, now I want to do a system call, and what do I do if things go wrong, right? I mean, the error handling here is really crucial, because if you get that wrong, then this thing just explodes, right? And possibly your Pony runtime too if you're doing it really wrong, and avoid that. But in general, I'd say the tricky bits are in understanding C types more so than understanding Pony types, which are much more straightforward, because the way they're used in those system calls, you basically have to go back and read all the header files to make sure that the context is correct and that your interpretation of an int here is what it's supposed to be. Does that make sense?
Yep, it does. So starting with something like a process passage that forks things and whatnot seems like a particularly difficult place to start using the FFI. If people were interested in diving into the FFI, can you think of things that might be good or that you did before you really dove into the process package that helped you get started and get a little bit of footing?
Sure. I mean, it would be much easier to just do things like, which is of course already supported in Pony proper, but as something there where you can have a learning experience is like reading a file, opening a file, reading a file, writing to a file, and doing that via system calls instead of using the facilities available in the Pony runtime. Mainly because as long as you run on a Unix system, that will teach you a lot about how those interactions work and how the FFI behaves, because everything in Unix, almost everything, is a file. And so if you know how to do that, then you can do most of all the other stuff. I mean, that you would have to figure out how to deal with the various flags you can set on file descriptors. You will learn about the flags, for instance, that we set here. Let me go back. Where do we do that? Right here, the top 3 lines where we set flags on the pipes, which are file descriptors too, which is fdcloexec, which means if I do an exec v in a fork process, then please close those file descriptors automatically. So you don't have to worry about that. If you set that flag, everything will be taken care of. And of course, we set a non-block flag to make sure that we can do asynchronous operations, which is also where we found a bug today, which still needs to be fixed. That seems to be related to the difference between OS X and Linux in a way they do asynchronous I/O and how you have to signal that to the operating system, to the kernel. And it looks like the bit twiddling you have to do here is different. So we'll have to basically have a compile flag here that interprets the flags differently and then feeds them into this make pipe function. So it's all about getting comfortable with using the FFI and doing that like in small pieces. That's what I did, writing small C programs. So I was like, okay, this is how things work and how they break. And then I did like a almost line-to-line clone of that in Pony, which wasn't Pony-like at all, but I mean, it did the things. And then I gradually shaped that into something that used an actor to encapsulate the interesting bits, create a notifier so that when something comes in, I can notify my client about new data. And then once all of that worked, then I did the work to make all of this asynchronous. So it's really like putting layers and layers, starting with the tricky bits, which is usually the system calls, and then gradually moving into I would say higher layer spaces where you can actually use the power of Pony to make things work reliably. Any other questions?
Going once, going twice. So, all right. Thank you, Marcus. That was great. It was awesome. If there's anybody who's watching this who is attending right now who's interested in doing one of these, drop me a line. You can find my email address on the Pony mailing list. I'm all over it. Thanks again, Marcus, and everybody have a good morning, afternoon, evening, whatever it happens to be, wherever you are. And hopefully we'll have something for you next month. Talk to you later. Bye-bye.